So this video is a little different from what I planned for this channel, as I originally wanted to cover history of vehicles in War Thunder, so that you could understand the reasoning behind why these vehicles were made. However, this video came around because there isn't much info on YouTube about Russian missiles, at least not modern ones. Also, we'll cover the philosophy behind them to understand why Russian missiles are the way they are. But we'll only be covering late Soviet and Russian air-to-air missiles. We'll get to the less than stellar ordnance another time. Russia's aerospace industry has shown remarkable ingenuity in missile design over the past 40 years, navigating both the final decade of the Cold War and the dynamic post-Cold War era. This period has seen steady evolution of weapons developed during the Cold War's twilight, the rollout of projects initiated in that era, and the creation of entirely new systems emerging in the 1990s. Today, operators of Russian fighter jets have access to an incredibly diverse arsenal of weapons. Many of these systems offer interchangeable components, such as airframes that support multiple seeker types or seekers that can integrate with different airframes. This ability underscores the sophistication of Russian missile technology. For Western military planners, this diversity presents a formidable challenge. An incoming beyond visual range missile could employ a variety of seeker technologies, including semi-active radar homing, active radar homing, infrared homing, or even passive X-band anti-radiation homing. On top of this, the missile's airframe could exhibit a wide range of kinetic performance, making it a nightmare to predict and counter. The aim of this analysis is to delve into the rationale behind Russia's beyond visual range missile capabilities, compare these advancements to their Western counterparts, and inspect the known derivatives of the most widely used Russian BVR airframes and seekers. Russia's approach to beyond visual range combat has its roots in the Cold War. Shaped by Soviet analysis of missile effectiveness, their studies revealed that low kill probability of missile seekers and airframes, especially when countermeasures were involved, could severely limit success in combat. By the 1970s, the Soviets had developed a unique tactic, launching two missiles in a salvo, one with a semi-active radar homing seeker and the other with a heat-seeking system. Some Soviet fighters were even equipped with a specialized weapon mode that automatically fired the missiles in sequence to ensure optimal separation and improve the chance of a kill. A common question is, why do Sukhoi flanker variants carry between 8 and 12 beyond visual range missiles? The answer is straightforward. They're designed to fire multiple 3 to 4 round salvos during the opening phase of an engagement. This tactic creates a nightmare scenario for the target aircraft, which must jam, decoy, or outmaneuver several closely spaced incoming missiles. Even with a modest kill probability of just 30% per missile, a 4-missile salvo pushes the overall kill probability to over 75%, making it an incredibly effective strategy. When evaluating the effectiveness of Russian BVR tactics, it's essential to compare them to Western approaches and the capabilities of the AIM-120 AMRAAM, the primary BVR weapon in Western arsenals. Introduced at the end of the Cold War, the AIM-120A was a groundbreaking fire-and-forget missile, featuring active radar guidance, mid-course inertial navigation, and data link support from the launch aircraft, enabling multiple simultaneous shots. Over time, the AMRAAM has evolved significantly. The AIM-120B brought incremental improvements, while the AIM-120C3 was designed with shorter wings to fit the F-22A's weapon bay. The AIM-120C4 added a larger rocket motor for better range, a shorter control section, and a more effective warhead. The AIM-120C6 introduced an advanced fuse, and the latest AIM-120D features a redesigned seeker for better durability under high vibration conditions, a two-way data link, GPS-assisted guidance, enhanced kinematics, and improved performance against high off-board targets. This continuous development reflects the West's focus on precision and adaptability in modern air combat. The performance of the AIM-120A, B, C models in combat has been underwhelming when compared to their stated capabilities. While test range trials for the AIM-120C boast an 85% kill probability across 214 launches, real-world statistics paint a different picture. In combat, these missiles have achieved 10 kills, including a friendly fire incident, with only 6 being genuine BVR shots. This was accomplished with just over a dozen AIM-120 fired, all against targets lacking modern defensive electronic warfare systems. Against such soft targets, the AIM-120 has demonstrated a kill probability of less than 50%. However, with the war in Ukraine, F-16 carrying AIM-120s have reportedly shot down 2 Su-34s, but the nature of the ongoing war means that this claim may never be verified. So where does this leave Western air forces? Take examples like the F-18E Super Hornet or the F-35. The F-35 in air superiority loadout carries just 2 AIM-120s, possibly 4 with upgraded models. While the Super Hornet can carry up to 12, this does diminish performance, so 6 is a more reasonable air superiority loadout, even assuming optimal conditions where flanker pilots don't exploit their superior missile number. A 2 to 4 missile salvo from an AIM-120 shooter might achieve a combined kill probability exceeding 90%. However, if hostile jamming and maneuvers reduce kill probability to 50%, a 2 missile salvo would only have a 75% chance of success, and a 4 missile salvo, while effective, would deplete much of the war load, leaving these aircraft vulnerable in prolonged engagements. The electronic combat environment complicates matters further. While AESA radars like the APG-79 and APG-81 can function as high-power X-band jammers against Russian radars, doing so risks exploiting aircraft anti-radiation missiles like the R-27EP or R-77P. By emitting predictable frequencies, these radars become vulnerable beacons. Russian radars may even employ seduction modes to exploit this weakness. On the flip side, infrared search and track systems such as those used on F-14 and now integrated into the F-18 and F-35 provide alternatives to radar tracking under jamming conditions. However, these systems do little to deny the flanker its own BVR shot. Assuming that defensive jamming and infrared decoys will consistently counter modern Russian missiles is optimistic at best, leaving Western forces facing significant challenge in a BVR engagement. However, shifting to the ongoing conflict in Ukraine, it's clear that Russia's air power and missile strategy have faced significant hurdles. Despite their technological advantage on paper, the Russian air forces have struggled to assert dominance over Ukrainian skies. Advanced Russian aircraft like the Su-35 and MiG-31, paired with formidable missile systems, have been unable to fully neutralize Ukraine's layered air defenses or secure air superiority. Ukraine's reliance on a combination of Western-supplied systems, innovative tactics, and advanced electronic warfare has posed challenges even for Russia's most capable platforms. This raises serious questions about the real-world effectiveness of Russian BVR strategies against well-prepared adversaries. While their capabilities are undeniably formidable in theory, the conflict demonstrates that no technology or strategy is infallible, especially when countered by adaptive tactics and modern, well-integrated defensive systems. It's a stark reminder that air combat superiority is about more than just equipment. It's also about how it's used, who's using it, and the conditions on the battlefield. The effectiveness of any missile is heavily dependent on its kinematic performance, particularly during the critical endgame phase of its flight, as well as the performance of its seeker and fusing subsystems, especially in a contested countermeasures environment. Historically, Soviet missile technology lagged behind the West in areas like propellant, airframe designs, and guidance systems. But by the 1980s, with the development of the R-27 and R-73 missiles, Russia began competing on equal footing or even outperforming Western counterparts in some areas. The R-73 in particular, a short-range missile, and the longer-range R-27 and R-77 have proven highly competitive with their Western counterparts, with the long burn variants of the R-27 even outperforming most Western solid propellant missiles. One of the most significant advancements for the Russians came with the development of the RVV-AEPD air-breathing ramjet missile. Showcased in the 1990s, this missile, which influenced the development of the Meteor missile for the Eurofighter Typhoon, introduced a new dimension to BVR engagements. The advantage of a ramjet-powered BVR missile lies in the ability to sustain thrust during the endgame phase, maintaining speed and maneuverability. In contrast, the conventional solid rocket missiles quickly lose speed when turning, giving them a limited capability in the final phase of the engagement. For extending the range of the R-77, options such as booster packs have been discussed in Russian literature, and larger diameter rocket motors with bigger propellant loads have been proposed. When it comes to missile kinematics, one factor often overlooked by Western planners, except perhaps for the F-22 and F-111 communities, is the influence of the launch aircraft's own performance. A supersonic Su-35 flying at Mach 1.5 at 45,000 feet can add around 30% more range to an R-27 or R-77 missile. In contrast, low-performance aircraft like the F-18EF and F-35 don't have this luxury. The range of their missiles is dictated solely by the missile's propellant and guidance systems. However, obviously with the F-35, the Su-35 would have to find the F-35 first. However, meaning in real-world combat, an AIM-120C or D might look better on paper. In some situations, it might be outranged by the Russian R-77. However, this is just theory. Let's actually have a look at the various Russian missiles that are in active service or possibly could be pushed into service very rapidly. The R-27 Vympel is Russia's counterpart to late models of US AIM-7 Sparrows, both semi-active radar homing. But that's where the similarities end. The R-27 comes in a wide range of variants and is significantly larger than its Western counterpart. The basic airframe is available in both long and short burn variants, offering different range capabilities. There are also versions with heat-seeking or data link assisted inertial mid-course guided semi-active radar seekers. The R-27 and R-27ER are the radar-guided long burn and short burn versions with the FPOL range of 17 nautical miles and 43 nautical miles respectively. On the other hand, the R-27T and R-27ET are heat-seeking versions with slightly lower engagement ranges. Russian sources suggest that the early heat-seeking versions of the R-27 use the 36T seeker, while more recent models have adopted the Mk80 seeker, which is also used in several high-off boresight R-73 Archer variants. One of the more unique versions is the R-27P/EP, equipped with the Avtomika 9B1032 X-band anti-radiation seeker. This missile is designed to target emitting fighters in the forward quarter by homing in on their radar emissions. It's the first anti-radiation homing air-to-air missile to be deployed in significant numbers, with a detection range of around 130 nautical miles. It's also known for being one of the fastest air-to-air missiles ever built. More recently, AGAT has introduced the R-27A and EA with an active radar seeker, the 9B1103M, which is based on the R-77 seeker. Although the R-27 is a legacy design from the late Cold War, just slightly predating the AIM-120A AMRAAM, it still offers impressive kinematic performance, especially in the long-range burn variants. Given its capabilities, the R-27 is likely to remain in production until it's eventually replaced by ramjet-powered variants of the R-77 family. The R-77, often nicknamed the Aramsky, this modern BVR weapon is designed to target 12G maneuvering threats and boasts a range of 54 nautical miles in APOL conditions, though some early production versions reportedly didn't meet the advertised kinematic performance, similar to early AIM-120 AMRAAMs. The R-77's AMRAAM-like capabilities allow a flanker to fire multiple rounds and guide them concurrently, depending on the engagement geometry. As the missile matures, we can expect improvements in propellants, autopilot kinematics, and seeker resistance to jamming. The R77M designation refers to both a ramjet variant and an enhanced version with a higher impulse rocket motor. The R77 has seen the development of alternative seekers as well. The R77T is equipped with a Mk80M heat-seeking seeker, derived from the R73M and R27T, while the R77P features an anti-radiation seeker. The arrival of the F-22A Raptor puts a significant pressure on Van Peel to develop additional seeker options, including the heat-seeking, anti-radiation, and electro-optical imaging seekers for the R77 and R77M to counter the F-22's superior kinematics and all-aspect stealth. While these seekers may not fully mitigate the F-22's advantage, they could still be highly effective against less advanced aircraft. The R77M PD, also known as the Ramjet Adder, is an advanced version of the R77 series, with an APOL range of around 18 nautical miles. This missile uses ramjet propulsion, much like the MBDA Meteor. The ramjet extends the burn duration and range, offering superior endgame G capabilities compared to the baseline R77 airframe. Another extended version of the R77 is the R77 ZRK. Developed as a surface-to-air missile, it features a much larger diameter fuselage to carry more propellant, though it's unclear if this variant has entered production. The modification to the motor section provides Van Peel with a low-risk path to further extend the range of the R77 design. The R37, developed in the late 1980s, was designed to provide an extremely long-range BVR missile for various Soviet fighters. Contrary to popular belief, it wasn't a direct competitor for the AIM-54 Phoenix like the R-33 was. Although the upgraded MiG-31M Super Foxhound serves as the test platform, Russian sources suggest the missile was originally intended for aircraft like the Su-35, Su-37, and I-42 MFI, as well as future fighters. The R-37's role also differs from the R-33. It was specifically developed to target ISR and EW platforms. Currently, the R-37 is in production for the upgraded Russian MiG-31BM Foxhound interceptors, and for export MiG-31BM aircraft, including those for Syria, until recently. While there were plans to integrate on the Su-27 Flanker series, there has been no confirmed reports of this happening yet. The R-172, originally designated the KS-172, marks a shift for Novator. The design is behind the long-range S-300V SAM system. Like the R-37, the R-172 was developed as an AWACS killer, designed to target airborne early warning and control aircraft at extreme ranges. The missile uses an active radar homing seeker, combined with inertial mid-course guidance. There are two known configurations of the R-172, one with a booster pack and one without. With the booster pack, the missile is claimed to reach a range of 215 nautical miles, while the range drops to 160 miles without it. The seeker performance is similar to the R-37, making it a formidable long-range weapon. However, nowadays, the missile is not in commission, whether in Russia nor in India. Supposedly, the development was stopped and the project closed by 2010. And that's a wrap at a look at some of Russia's most advanced air-to-air missiles. It's a little bit different from what I'd usually cover on this channel. Usually I focus on more aircraft designs than actual missiles themselves, but I think it's really important to understand where Russian missiles come from, especially for what this channel is really focused on, which is War Thunder. You should really understand what you're going against and what you're using, and it really shows what the future of the game holds, especially in terms of China, because they use a lot of the same philosophy that Russia uses. But it also shows that Russia still has competitive designs against Western counterparts, and it shows that their strategy is a lot different from Western counterparts, which has been the case essentially since Russian BVR tactics have been invented. But if you enjoyed the video, it would really help to subscribe, leave a like, comment or something. This channel is really new and I really want it to show more people, but thanks for watching. Next video is probably going to be an aircraft because this took quite a long time to research and put together. But anyway, thank you for watching.